One day in the Gotham City's bank representing the Skin, Bane the pathogen tries to commit a robbery. The Skin acts as the first barrier of defense against foreign objects, such as the Splinter. The body faces foreign invaders, and the inflammatory response acts as a non-specific response to slow down bacterial infection.
Right. Hello, good banker, sir. It is a very nice day out. Would you agree?
Yes, it is. Would you like to make a withdrawal?
Of course. I'll take everything.
Ah. Bane punches the banker, who represents the first general responders, which includes the mast cells and phagocytes. Mast cells release histamines when hurt. Surrounding damaged cells also release chemokines at the same time. The banker calls in signals for police, similarly to how histamine and other complement proteins for capillaries to dilate. Chemokines guide phagocytes to the area that can battle bacterial infections. The histamine is like the phone call. The chemokines are like the bat signal, which guides the responders towards the bank. Ah, Bane has broken into the bank. We need your help.
This bank is mine.
The SWAT team represents the capillaries and allow the cops and Batman to get in after receiving the histamine distress call by dilating. Dilating the capillaries makes them leaky, allowing plasmid and white blood cells to flow into the damaged site. This causes swelling, redness, and heat in the area. These macroscopic reactions to cuts are also caused by the release of chemokines.
This is a holdup. We'll wait for the reinforcements before we do anything drastic in case Bane tries to escape.
Let's secure the perimeter. Wait for the signal to let the cops and Batman through. Other than them, don't let anybody else in.
We just got the call. The cops are here. Let's open it up.
Dial it. Go.
The cops represent neutrophils and are the general white blood cell responders. They're responsible for slowing down pathogenic infections. They can be seen by pus buildups around the inflamed parts of the body.
Let's go get him.
Yeah.
Ah.
Just as the cops run out, no, Batman, the dark macrophage.
Get in my belly. Digest.
Batman, the dark macrophage, heroically and triumphantly eats the invading bacteria.
I'm kidding.
The cops, or phagocytic cells, re-enter the bank once it's safe and begin cleanup efforts, while the SWAT team, or capillaries, close up and secures the bank.
Well, we've done what we can to fix the bank. Now we have to leave.
Indeed, with time, the bank will be back to normal once again.
All right, Q&A time from the audience.
Questions?
So where are the chemokines released from? Like what releases them?
I can answer this. So signaling proteins and other such molecules are released by both damaged mast cells and phagocytes like macrophages and neutrophils that are usually the first responders to the site of the injury.
So chemokines act as like a guide while the histamine tells them that they should come here.
And chemokine concentration is the most at the site of the wound. So there's a gradient. So at the site of the wound, there's the most chemokines. As you move farther away, the gradient decreases. So it kind of acts as a roadmap for the macrophages and neutrophils to like follow that chemokine gradient to the site of the wound.
What's the difference between a macrophage and a neutrophil?
Neutrophils are like general first responders, and they're just like they're the most common type of white blood cell, and they're usually like parish. They're like one-use sort of things. So they usually get overwhelmed by initial invaders, whereas macrophages can eat invaders and like keep eating. So they're like longer lasting.
Macrophages are also larger, so they can ingest bigger invaders than neutrophils.
So that's why the macrophage was the Batman, and the neutrophils were like the cops. The cops can come in and save, but in the end they got overwhelmed, so we needed Batman to come in.
And what's one more difference between a macrophage and a neutrophil that wasn't mentioned? You mentioned two really good differences. Audience. Wow. We've got like the vasodilation galore going on here, red faces. Nobody? Hi, Sonica. How are you?
I'm good.
Tony? What's another difference between a macrophage and a neutrophil? I'll give you a hint. It has to do with specific immune response that may follow what they just showed you. Prince.
I'm gonna try and guess, but with the macrophage, when it consumes the pathogen, can it put like antigens like on the surface, but a neutrophil can't?
Yes. So a macrophage can become an antigen-presenting cell. So that's kind of the third big difference. You mentioned two, and that's the third big one. Okay, audience, in terms of content accuracy, you have the proper sequence of events. Let's see here. Morgan, do you think that they were fairly accurate in their portrayal?
Yeah, I think so.
Were they missing anything? I like the dramatic voice you're using. Yes, I do believe they were correct.
I'm prepping for our presentation.
Yeah, okay, good.
I think they had everything right. I think they had it in the right order. I think it was pretty well explained. I think Wiley did a really good job of connecting their example to these exact things that actually happen and explaining what they do in like the presentation and in our bodies.
Okay. Any questions from Pren?
No, I thought it was awesome.
Are you going to show everybody the big eye thing?
Not on the video.
Tyler, you have any questions for them?
No, I thought it was good.
Okay, is there anything that you don't understand at this point, Sonica?
At this point, no, I understand more than I did before the presentation, for sure. So, I'm good.
Okay. So wait, what were the things that released histamine?
Mast cells.
Mast cells release the histamine.
So in this case, the mast cells were like the banker, and like so the bank was like the skin, the first barrier he broke in, and Wiley was like the mast cell. Once
he was injured, he released the called them out.
And what were the functions of histamine again? I know you acted it out, but just to reinforce it for the audience.
Alright. Histamine causes the capillaries to dilate so that phagocytic cells such as neutrophils and macrophages can move to the site of infection or injury.
It also makes the capillaries leaky, so the the white blood cells can get out and get to the infection site.
Okay. Are there any other sorts of chemical messengers, audience, that are involved in a non-specific inflammatory response that weren't mentioned here? That are part of our targets? You guys are so shy on video. See, this is dead air time. This would be really bad on TV or radio. Well, what do pyrogens do?
So pyrogens create heat, or release heat, so that, well, we don't exactly know why pyrogens, or why heat is involved in the inflammation process, but it might be because heat can speed up enzymatic processes and allow macrophages and neutrophils to digest faster.
And possibly denature necessary proteins for pathogen invaders? Okay. Anything else that might be involved in general inflammatory response, either at the site or systemically throughout the whole body?
Well, there's clogging also at the site to prevent the infection from spreading out through the body and pretty much to confine the infection to that specific area.
Okay. All right, last call for any sort of questions? Okay.
I don't know if this specifically relates to the inflammatory response, but what's the difference between a chemokine and a cytokine?
There is no difference. Right, so chemokine, cytokine, lymphokine, they're all chemical messengers. Cyto just means cell, so any sort of a message that is released from a cell that goes to another cell is a cytokine. Lymphokine would be a specific type of cytokine that we see in lymphocytes. And what was your other, you said chemokine?
Yeah.
Chemokine is just another general, like, chemokine chemical messenger. So for our purposes, you can take all three of those vocab words and lump them together. They all mean the same thing. Last call for questions from this group, or for this group, excuse me. All right, thank you.